This problem is asking us to draw all the contributing resonance forms, starting with this first one. And right away I see that I have an allylic lone pair, meaning a lone pair that's next to a pi bond. And I can actually start with the lone pair on the nitrogen and either go to the left or to the right, whichever one I see. But I'm going to start by going to the right. And so that resonance is going to be allylic lone pair resonance, means the lone pair becomes a pi bond, and then the pi bond becomes a lone pair. So when I draw that result, I'm now going to have just one lone pair on the nitrogen and a pi bond between this nitrogen and a carbon, and then a lone pair on this carbon. And then this pi bond over on the left has not changed. So this would be a new resonance form. And now I see that the nitrogen is neutral because it has 5 electrons around it. But this carbon with the lone pair has 1, 2, 3, 4, 5, and it only wants 4, so that's where my negative charge is now on this carbon. And I can continue doing allylic lone pair resonance. The lone pair is now allylic again, so lone pair becomes a pi bond becomes a lone pair. And so the third resonance form has a lone pair on this carbon. And let's see if I can draw that a little better. And now this top nitrogen hasn't changed, but now there's a pi bond between these bottom two carbons, and so I can look around and see that all these carbons have 4 bonds, except this carbon up here has 3 bonds and a lone pair, so that's where my negative charge is now. And I can continue with another allylic lone pair resonance. Lone pair becomes a pi bond becomes a lone pair, and that brings me now to a structure where the lone pair of electrons is on this carbon to the top right. And so nitrogen still has one lone pair, pi bond is here, and this bottom pi bond has not moved. So where's my negative charge? Notice that the negative charge keeps following that extra lone pair of electrons, so now this carbon has the negative charge. And then there's one last resonance form where my allylic lone pair can move once more, lone pair becomes a pi bond becomes a lone pair, and my pi bond is here, and my lone pair is now here, and this pi bond hasn't moved. And where's my negative charge? Now it's on the carbon on the bottom left. And if I did one last resonance with this final allylic lone pair, you'll see that it's going to actually bring me back to my original. Lone pair becomes a pi bond becomes a lone pair. It brings me back to my original resonance form. So there's actually 5 total resonance forms. You can see that the negative charge is completely delocalized in this case over all 5 atoms in the ring. And if we had to rank which one was the best resonance form, we want to look at where the negative charge would like to be. And we have either an N- or a C-, and because nitrogen is more electronegative, it prefers to have the negative charge there. So this is the best resonance form out of all of these. So the resonance hybrid looks the most like this, with the nitrogen bearing the majority of the negative charge. But in fact, all of the 4 carbons in the ring also have some anionic character.